Hi everyone, I am Vicky from the Silicon Circle, and yeah, today I have came up with a session. I'm going to explain about a one very strong technique which is getting utilized in the industry right now, and that is called a pseudo LRU techniques. Okay, so let me explain what is a pseudo LRU so that you guys will understand in a detail. So what I'm going to explain you guys, that is called a pseudo LRU. So what is pseudo LRU? What is LRU first? Actually, this term tells regarding कि cash eviction method. You know, right? कि we need a cash organization in modern processors so that our processor will be more efficient in terms of performance. Okay, if we want to increase the throughput, if we want to reduce the latency, so we need a particular memory hierarchy. Okay, so that how a data can communicate and how a chunk of data will get propagated in each stage of our processor's pipeline to do some useful tasks. Okay, so what LRU tells, LRU means what? Least recently used. Okay, and actually what is the pseudo LRU? It is a cache replacement policy. रिप्लेसमेंट पॉलिसी. ओके, कि हमें कैसेट से किसी पर्टिकुलर एलिमेंट को यदि हमें इविक्ट करना है, लाइक इफ विल हैव टू इरेज सम पर्टिकुलर लाइन ऑफ कैसेस, and if we have to bring a new data from the memory and we have to put in a caches, so which line we have to erase, so that we have to follow some rules, some guidelines. So this algorithm, there is a lots of other algorithm also related to cache replacement algorithm, but I am going to discuss today a pseudo LRU. Why I have picked this? Because industry right now uses this algorithm in a modern processors. Okay, so what is the pseudo LRU? As I explained, it is a cache eviction or replacement policy algorithm. Okay, so where it got applied? Ideally, industry prefers right now a set associativity cache organization. Let me write कि each industry right now working on the set associativity cache organization. Okay, what is that? If someone will tell कि I have a caches which support a n-way cache. Okay, then what it means, if let us suppose we have a bigger cache block. So if in a cache block, if we have a n number of sets, okay, if it is a set 0, if it is a set 1, and so on, if it is a set n. So if in each set, what will happen, we'll be having a n-way, means we'll be having the n line of caches in each set. So this is a way 0, this is the way 1, this is the way 2, and dot way n. Okay, so line, the n way means the n line of caches exist in a particular set, right? This is clear. So how this memory controller works, you know, कि if we get some particular address, we break it in terms of set, index, and offset, right? So sorry, tag, index, and offset. So index tells कि which set to go, okay, and offset bit tells कि in that first of all we head towards the set, कि which set to select, and that tells index. So index points about कि which set to choose. Then tag tells कि which way to choose. Okay, means which line from a current set to choose. And offset tells which byte in a line to choose, right? कि first byte or second byte or third byte in a particular lines of cases which sits in a set to choose. So guys, I have explained in a very high level knowledge कि always in a set associativity mapping we like break down a particular address into three parts. One is a index, one is a tag, one is a offset. So always index points कि in which set to look. A tag tells in a set which way to look, and a offset tells in a particular way which byte to look. Okay, so let me write here whatever I explained. कि index tells कि which set to look, tag tells which line or way in a set to look, right? And offset tells which byte in a way or line to look. You understood, right? So we always divide in terms of three things in a set associativity mapping. Yeah, clear till now? So now guys, as I told you, let us suppose by the knowledge of index, okay, if index told you कि hey, select a first set, you went to a cases, you started looking a set 0, okay, set 0, and let us suppose कि your set 0 is organized in a four-way structure. Four-way structure means in each set you will be having a four-way. You understood? Four-way. So way 0, way 1, way 2, way 3. Let me write here. It is our way 0, way 1, way 2, way 3. And extremely sorry, I have drawn other line. Okay, fine. And let us suppose that then you will start the matching tag. Tag value will tell which way to look, right? As I explained. But that tag is not available in your cases. So tag array didn't matched. Then what it means? Your current data is not available in the cases. Then what you will have to do? You will have to bring that data from the memory to the caches. Not only that data, a block of data, a bunch of data, so that from the next instruction you will hit a caches and you will save the performance, right? But to bring a new data from the memory, you will have to remove the existing some particular ways, right? Either you have to remove the way 0 or way 1 or way 2 or way 3. So which way will be the victim to get removed? You'll have to follow some guideline for that, right? You can't do any randomness. Ki hey, it is full. Just you are following any random ki bhai erase the way 3 or erase the way 2. Okay? Because if you are following that, ki how you are, if next time wherever you have erased and the same block is getting requested in the next cycle, then you missed, right? Again, your performance will get degraded. So you'll have to follow some the guideline. And as I explained, that LRU is that guideline. LRU means we are going to evict a particular line of caches in a set which is least recently used. Okay, LRU means least recently used. So now, what industry are preferring? Industry are preferring the pseudo-LRU. Why not a normal LRU? You guys might be knowing for a normal LRU execution, in each way we have to attach a counter. But if you are going to attach a counter like C0, C1, C2, C3, hardware will become very bulky. Right now it is a 4-way. Okay, let us, and here in each way you will have to keep a 2-bit counter, right? If you are now, let us suppose in future you are making a 8-way, right, set associativity organization, then you will have to bring 8 counter, parallel counter, and we have to attach with each way. So this is not a scalable solution because your hardware will become very bulky. So industry is not preferring a normal counter based algorithm for a like this eviction technique. So what industry are preferring right now, that is called a pseudo-LRU. Short form is PLRU. Okay, pseudo-LRU. So how it works? So always a pseudo-LRU, if you have a n-way organization, then you will need a n-1 bit only to implement this algorithm. Okay, n-1 bit are sufficient to implement this particular algorithm. Now let me describe that algorithm. As I explained example, we have a 4-way set associativity cache organized in our processor's memories hierarchy. Okay, so we have a 4-way. It is a way 0, way 1, way 2 and way 3. And as I told, for an n-way, if we are preferring a pseudo-LRU, we will need a n-1 bit. So here how much bit we need? 4 minus 1, that is only 3 bit required. 3 bit required. Okay, so it is a binary tree type of implementation. Okay, and that is going to point, and they are going to tell which is a least recently used element, so that we can evict algorithmically. Okay, very good. So we need a 3-bit, right? Only 3-bit. So let us suppose we need I will mention that 3-bit like this: B0, B1 and B2. So how it getting organized? Remember guys, always node, as I told you, it will be a binary tree based implementation. So always the B0 will tell about the root node. Okay, ye jar hai, jar. B0 is a jar. Remember this. Now, always B1 and B2 will be the leaf node, but B1 will sit in the left side and B2 will sit in the right side, right? And then way 0, way 1 will be a leaf node for a B1, and way 2 and way 3 will be leaf node for a bit 2. You understood? So like this, now we have to keep on updating the B0, B1, B2 value, and then B0, B1, B2 value only will tell what will be the victim, right? So let me explain the algorithm now. Let us suppose in the beginning everything in the reset. So by default, way 0 will be the eviction. Remember, 0 means you have to move left, 1 means you have to move right. 0 means left, 1 means right. Okay, so let us suppose in the beginning B0, B1 and B2 all are 0. Let me write in the tree diagram itself. So it is also 0, B1 is also 0, B2 is also 0. So if B0 is 0, what it tell? Move towards left. Now if B1 is 0, then what will tell? Move towards left. So V0 is the victim. So use the way 0, right? It is a very simple. Okay. So now way 0 is a most recently used. Remember, what is way 0 is the MRU right now. Okay. Very good. Nice. So now, let us suppose that you are using the wave 1. Let us suppose wave 1 got utilized. The next cycle, wave 1 got utilized. So update a bit B0, B1, B2 such that it will move away from the wave 1. Remember this thing, away from the wave 1. What we are utilizing? Wave 1. So how we can move away from the wave 1? Where wave 1 sitting? Wave 1 sitting left side of B0. Let me erase now because we are going to update all the value, right? So let me say, sorry, earlier it was the 0, 0, 0, right? Let me write again here. Sorry, let me revert the changes, whatever was the earlier. Okay. So earlier one, all the 0. Now let us suppose ki we have utilized the wave 1. It got used. So we have to move away from the wave 1. So how to move away from the wave 1? B0, you have to keep 1. Because if B0, you have to revert to the 1, then only you will move towards the B2 and you will not come in this branch. So first thing, you have to switch B0 from 0 to 1. So this transition is the necessary. Okay. And as you are in the wave 1, so if B1 is right now 0, right? If B1 you will move 0 to 1, then you will come to the wave 1. As I told you, you have to move away from the wave 1. So keep B1 as a 0. Okay. So that it will go away from the wave 1. So it have went to the this side, away from the wave 1. Right? So 0 will be to the 0 only and B2 will be the unchanged. So the what will be the new B0, B1, B2 value? It is the 0. 1 minute. So our earlier value was the 0, 0, 0. And when we have utilized the wave 1, our the new data, let me write here like that, V0, V1, V2. And our new field will be, because we have used the wave 1, okay. So we have to move always away from the wave 1. So how we can move away from the wave 1? We have to traverse towards the right side because wave 1 sit B0 left side. So to move the right side, we have to switch B0 to the 0 to 1, right? So V0 change to 1. And what about the B1? Because if B1 will switch from 0 to 1, we will move toward the wave 1. But as I told you, we have to move away from the wave 1. So we have to keep B1 0 to 0 only, so that we will move the left side from the B1, that is a wave 0, right? So B1 will be 0 only and B2 will be unchanged. Very good. Now let us suppose in the another cycle, wave 2 got utilized. Okay. Now let us suppose wave 2 got utilized. Now if wave 2 got utilized, where we have our wave 2, here we are sitting. As I told you, we have to update so that we'll move away from the wave 2 now. So wave 2 is in the right side of B0 path, right? So instead of moving towards the right side, we have to move left side, so that we'll move away from the wave 2. So again, we have to switch B0 from 1 to 0. Okay. And what about the B2 value then? Because if B2 will be 0, then always 0 means left side. If B2 you will bring 0 only, you will have to move towards way 2 only, right? So you are moving towards way 2. But as I told you, algorithm is like that, we have to move away from the way 2. So we have to switch B2 from 0 to 1. right? So B2 will get switched to 0 to 1, so that you will move towards the way 3, not towards the way 2, and you are moving away from the way 2, and this is satisfying result. So what changes we require now? So in the next cycle, what will become? B0, because you have to move away from the way 3, right? So sorry, we have to move away from the way 2. So way 2 is right now where? It is in the right side of B0. So you have to switch back B0 towards the left side. So B0 will become the 0. Now what about the B1? Because B1 is unchanged, because B1 is the left side entirely, because you are moving away from the way 2. So only B0 and B2 can decide, right? Not a B1. So B1 will be the unchanged. So B1 will be unchanged. Again the 0. Let me write. 1 minute. So B1 is unchanged, that is the 0. And what about the B2? Because B2, if you will keep 0, you will move towards way 2. So it is prohibited. You have to move away. So you have to switch B2 to 1. So here B2 will become 1. Right? Nice. Now let us suppose कि again what happened कि way 3 now got utilized. Got utilized. So if way 3 is getting utilized, again I am telling you you have to move away from now way 3. So how to move away from the way 3? How to move away from the way 3? First of all, B0, you'll have to keep on moving towards left. So B0 will be again 0 to 0 only. So here what I'll write, ki B0 will be 0. Who will decide? B1 will decide. No, B1 will be as it is. So B1 will be again 0. What about the B2? Because you are now using way 3, you have to move away from the way 3. So B2, you'll have to switch from 1 to 0. Because if you will be 1, then 1 means right side. You are moving towards way 3. But you have to move opposite to the way 3. That is called the way 2. So you have to switch back B2 1 to 0. Right? So B2 will become the 0. Right? So now you can see ki the new state will be, bit status will be 0 0 0. So now as we have used everything, way 0, way 1, way 2, way 3. Now let us suppose another block. Now let us suppose ki cache miss happened. Now because now we have filled our blocks, right? Our each ways got filled. Now let us suppose ki cache or miss happens. Cache miss happens. Then we have to evict, right? So what you are going to look? We are going to look only the B0, B1, B2 field to select a cache eviction element. So what you are saying, you have a B0, B1, B2 updated to the 0 0 0. So now we will go to the binary tree diagram. If B0 is 0, you are moving towards left. Okay, you came to the B1. Now B1 is also 0. So you are coming to the way 0, right? Left. So way 0 is a here eviction element, or you can say victim. So you are going to erase way 0 and you are going to bring new data and you are going to fetch here. And as you remember, ki in the very beginning we accessed way 0, right? And way 0 is the least recently used, right? Like that you can apply through any example, any particular things you are going to sequence you are going to choose, and this particular algorithm will always tell you in the final stage about ki which element can be the victim to get erased. Okay, if caches, wages are filled completely. You understood, guys? So what I have explained right now, a simple 4-way set associativity pseudo-LRU algorithm. Okay, and in the next session I will come up with a hardware implementation of it, ki how HDL will look like. Will integrate that hardware in a pipeline also, okay, processor pipeline also, so that this algorithm will keep on running whenever a instruction fetch happens through the instruction caches. Okay, so we are going to implement that. And for like your workaround, you guys can keep on practicing with a different following sequences, and you can see कि this algorithm is very efficient, okay, because we need a very less amount of hardware to implement this also, okay, and it is very effective, and industry right now is using the pseudo LRU algorithm only for a cache eviction methodology or cache replacement algorithm, okay, and I am giving you task. You guys can implement a similar diagram for 8-way set associativity organization, okay, and paste your answer in my groups, okay, and if you guys have any doubts, you guys can ask me in my group. So thank you, bye bye. This was a short lecture related to the pseudo LRU algorithm. Thanks.